Well, it's official, folks. Looks like we can get started. Today's class is going to be kind of light. We're mainly just introducing the class, running through the syllabus, but not a careful reading, and just looking at some of the elements that you're going to see all over the Moodle website, just to get used to the flow of the class. Before we get into all that stuff, though, any questions that folks have right away to start us out? Okay, sorry, go ahead.
Sorry, what was transcendental?
Yes, it should say Functions Early Transcendentals, 9th edition by Stewart. Let me get some better detailed information on that. On the syllabus right here on the second link, you should see it here on course text. I have an ISBN. I should put that on there. Let me actually put a note here. Well, it is the Stewart book. Yeah. Awesome. I'm also going to make a post here if folks are tracking down a cheaper copy. I'm going to post the ISBN to that thing.
Have to be the latest edition, 6th edition.
6th edition is going to work. That was an earlier question in class. One of the things I'm going to be adding to my homework sets is on here. It's not here at the moment, but if you click on it, say by Wednesday, probably on Tuesday, let's say Wednesday, give me a little bit of a breather on that. You'll see documents down below here that's going to be PDF to the actual exercises you'd be solving out of the 9th edition. So the sections are all the same, different problems pretty much. Yeah, you bet. I was saying just earlier, I learned this out of the 5th edition. It's really not different at all, hardly.
Sure.
So you're in good shape. Other questions so far? Okay, now that we're talking about the textbook, this is my third class of the day, and everyone's had a pretty okay experience with Book Bundle, but there's been a lot of weird situations. How's the ISU Book Bundle, the thing that's new this semester, treating you all? Have you opted out, opted in? They put shipping on that. That's not something they told us. I should make a note of that. They, oh, yeah. They add shipping if you can't pick it up. That's really rough. Yeah, it starts to lose its value prospect once they add all these extra charges on there. Thanks for mentioning that. Yeah, I should mention they gave us some information on the book bundle, but ISU is also in a weird position because contract time starts on the 12th. If they give us too much stuff in the middle of the summer, suddenly they have to pay us for all 12 months, and that gets costly, I guess, for the state. So they dropped a bunch of information on us on the 12th, and we're all just kind of scrambling to figure it out. So if anyone has any trouble getting the book through the book bundle, if there are any kind of problems, just let me know right away. If you're still waiting to get your book, I'm going to add an ISBN number right here so you can compare if it's cheaper to just get something online from an online seller or something used, something like that. And really, this is going to be a highly, highly traditional course. There's no WebAssign, MathExcel, or anything like that. Our problems are going to be done in a traditional way. I added some information there we'll discuss. So really, you're just looking for a cheap edition of the textbook. I studied it out of the 5th edition. I'd say 5th and upward is a good call. If you go to the 2nd edition, that's going to start looking a little bit weird at that point. I'll be posting the problem set so that everyone will know what problems you're really doing, no matter what edition you're working out of. But we'll be paying attention to that book bundle stuff. There's problems that are coming up on your end. Please let me know right away, and I can push things up to the administration, yell at them a little bit, see if they can get it figured out. I think this class kind of has the easy end of it. Other classes that had like a WebAssign component has been a little bit more disastrous, but we'll figure it out as we get through. So let's start running through things. I've used the announcements forum for the first time last semester, and I'm continuing to use it. So if you jumped into this course, maybe just on Friday last week or anything like that, any of the announcements I put out, you can open up here and read through them. It's just the one announcement right here. I'll let you take a look at that. Nothing too major, just kind of general stuff, Zoom link and the like. So pretty much everything is going to happen on this Moodle webpage. We'll go through this document here in a little bit of detail, but we won't be bored to tears reading it line by line. One thing I should mention right away is there's a calculator policy. And I don't ask a lot of calculator questions. It's more of a comfort, but For the odd computation where you really need one, these are the two calculators allowed on an exam. This one right here is highly recommended because it just has a lot of creature comforts for typing in a value and computing. If you use this calculator, the TI-30XA, it works just as well, but it's a little bit more finicky. You have to essentially do order of operations in reverse. If you're really well practiced with that, you'll be just fine in this class. And this one is the one I generally recommend here. I think it costs something like $15 or so. So that's our recommended calculator for exams. I always let you know if there's going to be a problem on it that specifically requires a calculator, so you won't have out of nowhere a requirement of typing in a bunch of stuff here that you didn't expect. Yeah, go ahead.
That's pretty excess.
The 30XS is going to be just fine. I'd be okay with that. Pretty much what we're trying to exclude is graphing calculators. I'm sending exams to at least 4 different testing centers, so this is more to keep it uniform. So if it's close to this and not say like a TI 34 CE or something like that, you're just fine. Other questions at the moment? Okay, so that's our calculator policy on there. The Zoom link is posted here, and I understand this is a night class. So even if you're registered for the in-person section, if there's a night that you just can't make it on, but you want to be here at least through the internet to participate, then you're welcome to use that link. So don't feel as if you're excluded just because you're in the in-person section. And conversely, around the same token, for the folks who are on the fully online section, this one right here, a lot of us are far remote, but some people, if you can swing by the class, you're welcome to do so. So don't feel just because you're in the fully online section, you're specifically banned from this classroom. This seats 50 people. There's never going to be an issue there. And I'd say learning this kind of stuff, that's better in person. If you can't make it in person, it's definitely better in Zoom. If you're here in person one way or another, that's always the better way to learn this kind of stuff. But if you can't make it at all, stuff happens. I mean, that I've had to cancel classes myself due to health reasons and such. I do record all my classes and they'll end up right down here into a YouTube playlist. So that's another way to still at least capture the class. It's just impossible to participate in that point. I should mention, some people have made use of, if you're looking at a recorded lecture and you pause it and tell me, hey, Mike, on the video on the 19th of August, 52 minutes in, you said this, and I just didn't quite understand what you meant. I don't have any opposition to going into that video, taking a look and seeing if I can clarify. I might just sometimes say, I have no idea what I said. Here's what I probably meant, but I can be happy to clarify those kinds of things. So that's the Zoom link. The record lectures end up here. And this is just some optional reading that you might find interesting. Why study calculus and how to study calculus. This one right here is from the legendary online math instructor from Lamar University, Paul's Online Notes. So this one tells you how to study math, but I found it personally, even though it's getting kind of old looking, it's a very well functional website for just about anything you want to look into. It's good for studying for exams for this course, reviewing further, and so on. And people find it's an excellent resource for Calculus 3 differential equations. So this is a wonderful website. It's kind of old school, but it still runs really quite well. The reason it's here is if you feel like you need to change up your study methods, if you feel like you're spending a lot of time studying for minimal return, then this is a good write-up of one things you could look at, one things you can think about, with other articles down here as well. For example, like taking notes. Sometimes you find midway through your career as a student that what you did before just isn't cutting it. You need to make a change. You can click on these things to just get a feel for what are some ideas out there. Some of these might not work for you. Some of them might be fantastic, but it's good to see what all the ideas are so you can come up with your own plan on how to study, how to take notes, and those kinds of things. So that's the purpose of, this one's just an article. This one's a whole resource of interesting things. And now we're talking about taking notes. This is essentially how the course is going to work on a week-by-week, day-by-day basis. The notes over here start out blank. Let's open one over here and as a PDF. But once we start working through these, we'll have it all filled out in here with what the solutions are. I'll be posting the solutions in this location. If you need a blank set of notes, click on this folder. And usually I upload these. Sometimes I forget. So if you see something that's missing, like today, just let me know. We'll get it fixed right away. Let's see if we can fix this in real time. Should have been 7.1. We need it as a PDF as well because I use the equation editor on this Word document. So if you have an older version of Word or a janky version of Word, that might not print out too well. But if you open the PDF, these are always stable documents. So if you need to come up with a blank set of notes, you can always come here to find them. And the purpose of all this is sometimes people find that, well, depending on how you take notes, you might do just fine using ordinary lined notebook paper, bigger than this probably, and just writing down the problems as we go. Other people might download these, print them out, or maybe load them onto a laptop. Anything like that could work great, and just write them in yourself. But the major purpose of having this all available is sometimes, let's see if I have anything here, maybe sort of right here. Sometimes there's a lot of stuff thrown into the notes, and I don't necessarily want you to copy this down. A lot of this stuff is verbatim out of the textbook anyways. I mean, it's like you're copying out the textbook. So this is more of a structure for you to know when ideas come in, not feel like you have to copy them down verbatim. You'll be copying down the actual solution process down here more likely as you take notes. Some people find that copying down notes is too much a distraction, even if it's the step-by-step solutions, and they might learn it a little bit differently just by following along. It's all up to you, but I would say as general advice for note-taking, the more of your senses that you can pull in, the more that you're doing while you're taking notes, the more the brain just seems to retain. The simple action of just moving your hand is traction on your mind for remembering those concepts. It's really kind of weird like that. So that's how the notes are going to work. That means these will often change as we post our solutions. I indent things as well on the Moodle website. Sometimes I put in supporting documents. For example, this one is just kind of a refresher on some common differentiation rules. It's also a way for me to say what stuff are things that you have to retain for purpose of exams. These wouldn't be formulas that we're posting. Well, they're typical differentiation rules. Here's the good old chain rule. We need to know our derivatives for trig functions. These are particular inverse derivatives that just come up over and over. These are ones you're probably just going to memorize just because you did the homework that comes up so often. We need to know about our logarithmic derivatives. This one's common. This one's a curveball. I don't do this a lot on exams, but it could come up on homework where you're doing a different base logarithm, a different base exponential, and so on. We need to be aware of our hyperbolic derivatives. When you look at this list for hyperbolics, there's really not a huge difference from the one with the trigonometric ones. Let's take a look. On this list of trigonometric derivatives, the one change when you go to hyperbolics is that negative sign right there moves to that side. It's essentially the same thing except your functions say secant h, tangent h. So that's a list right there. Memorizing these are something you really pick up quickly after doing homework. And this is just a list to refresh, coming from Calc 1 to Calc 2. So that's the purpose of those files. The homework assignments are going to be posted right after the notes in this kind of fashion. I try to put in a 1-week turnaround for the due dates on these notes. My due dates are flexible. This is not a hard due date. This is more of a guide for you to be caught up on the course. This assignment should be completed by August 28th. The reason for that is we should have those notes done by the 21st. So that gives you a 1-week turnaround to work on the problems, ask questions, get them handed in. There are a lot of ways to hand in this homework in this class because we have 3 different kinds of classes all glommed into one, the in-person section, the online section. And so here's how you could hand in your homework. Let's go through these. If you want to do this fully traditional, just get some paper, could be lined or just blank like this. Write out your solutions, step-by-step solutions on your homework. Hand it in at the front of class before or after class, and I'll grade it in a traditional way with a pen, return it when I next see you. That doesn't work for everybody. There's some people would have to drive for about 7 hours to turn in homework. So second method is, you're still doing the, oh, sorry, question first.
You don't turn in.
You do not. I'm okay with different ways of turning in. You could turn in on just, for me personally, this is my personal preference. When I'm doing math, I just take a completely blank piece of printer paper and just start working it out. So if that works out for you, just fine. If lined notebook paper just is better, go for that. I'm gonna leave it up to your preference in this class. Other questions so far? Okay, so again, if you're doing it on paper, but you live hundreds of miles away or something like that, just scan your work. You don't need a scanner. You can use your cell phone and that'd be fine as well. Directly email it to me at mikejacobson@isu.edu here, and I'll grade your homework digitally. So this has some ramifications though. If you turn in a hard copy, I can't get it back into you until I see you next in class. If you turn in a digital copy, I just email it back to you as soon as I have it graded. So the way you hand in your homework sometimes has to do more with how you would like to get your homework handed back. So that's one thing to consider. Third way is some people may not do anything traditionally. You might take out a file, say like this one on the notes. Pretend this is your homework set. I'm not sure what program you might be using. It could be Microsoft Word, some equivalent program on an Apple platform, or so on. If you start solving out stuff like this, I'm just writing out random equations. Then just convert that to a PDF, directly email it to me, and I'll grade your copy digitally and return it to you as a digital format as well. So those are the various ways. There could be some other unique situation. If this doesn't fit you, method 1, 2, or 3, just email me and we'll work something out. Does that make sense to folks so far on turning in the homework? Awesome, glad to hear that. We'll figure out more about this as we go. So think of assignment 1 as we're just getting used to all this stuff. I put a lot of bullet points here. I don't say this on every single one, but we'll come back to these things. We do have to have correct mathematical notation. So for doing a derivative, we must indicate it. For computing a limit, we have to say as x tends to what the value may be, those kinds of things. Some of the problems we want exact numerical values. Those are going to be the definite integrals in this problem. It's okay to put a numerical result inside. Say, for example, if you have something of this quantity, square root 2, but you gave me 1.4-ish. I'm looking for this, the exact value. That's what I mean by give exact values. If you also approximated it, that's okay too. As long as I see the exact value, that's the major thing I'm looking for on those two problems right there and there. Aside from that, there's a couple other guidances right here, but we'll come back to this statement as we're solving the problems ourselves to see what's meant here. But essentially, this is just saying, show your work. If it's a U substitution, you should say what the U is and what its differential is, and so on. So that's assignment 1. And I'm going to add some extra stuff to assignment 1. If you're again in the, say, the 6th edition, 7th edition, 8th edition of the book, those are all wonderful. The problems are out of the 9th edition. And if later on, if you click on here, I'll demonstrate this once they're posted. I'll have a PDF copy of your actual exercises right down here. So we'll know we're doing the same and correct problems. And by the way, if you're hunting for an older edition of the textbook, be really careful with the edition you buy. I'm going to be specific with the ISBN. I'm going to upload it right here. I have a note of things to do that I forgot. That way you'll know you're in the right one. And here's what kind of goes wrong. You might think you're buying the right 9th edition, but there's like 3 versions of the 9th edition. Some courses or some universities approach their material slightly differently, and they've made actual literal different versions for the 9th edition there. Really kind of annoying, so watch out for that. Other questions at the moment? Okay, so that's pretty much the Moodle website. If this was, say, 3 weeks into the course and we were all coming in for the class to start, I'm always going to have it scroll to where we're at. The next thing we're going to look at, I might jot down some notes or things like that, a couple doodles, but that's how pretty much the course will run. Any questions at all, folks, online or in person? Yeah.
Are we campus resources?
Oh, yeah, absolutely. Yeah, I kind of got excited looking at the Moodle resources here, so I think I just got stuck running through them. But yeah, we eventually have to get through right here, the actual syllabus itself. This document hasn't been revised, but I am going to revise it shortly. Any changes I make are going to appear in red. We're going to see the ISBN number in red just to say that's something new that was put in after the first day. But here's pretty much how the course is going to run through the syllabus. We're all pretty much set on class meetings. We're supposed to end at 8:07. You might find typically we land at like at 8:05 or 8:04, since our problems can take 10 minutes easily. So we'll try to hit that, but we'll have to fudge it a little bit to get close. I try not to go over. I realize people have places to be, especially for a night class. So if I am at 8:08, I made a mistake and you guys need to make some rustling, putting things away to indicate class is over, or I might forget and just keep going. I try to look at my clock to keep on task. Aside from that, the way you can contact me is you can directly contact me through the cell phone number. It's a tough way to get me since it's usually silent, but I'm very highly responsive through email, this address right here. And you can email me just about anything. It could be a question about the class. You could let me know you might not make it, things like that. Also, if you're working the homework, you might say problem number 13. If you're having a hard time getting through that one, I just randomly selected it. Work it out, get as far as you can, send me a picture of what you've done. You can directly email that to me, and that's a way of doing office hours, but purely just over the email. I'm always very happy to take those kinds of questions. And every time I mention that, I also mention this. People don't typically take it seriously. You really can send as many questions as you like. You're never going to overwhelm me, even if you have a lot of questions. Don't feel like you're badgering me or anything like that. I've worked with certain students where it tells me the number of emails we've had is not even a number, it just says many. So that's never a problem. It's literally my job to support you through this material. So don't hesitate to write. Even if you're just not sure how to start a problem, send that as an email. I'll be happy to help. But it is over email. That's hard. It's not immediate. You have to be really patient with that. It could take me some time to get a response out. So for more immediate help, I'm going to be in, let's see, 2:30 to 4:30 p.m. in room 220. That's across the hall over there, just kind of sitting there. These office hours in room 220 are usually kind of dead. So usually you can get some pretty good help one-on-one and that kind of thing. If it's busy, I just go in the order that people showed up. And you can't show up there completely unannounced. No appointment is needed. You don't even need to have a question. Sometimes people just show up to room 220, start working on math, and a question will come up and they'll ask at that point. That's completely fine as well. It's a good room for study groups, but I do have to lock it at 4:30 p.m. That's the worst thing about it. It also has another office for the writing center. So if I'm the last one there at 4:30, the worst part about it is I have to actually physically lock it up. I have to kick people out when they're working. It feels kind of awful, but that's how that one works. I also have office hours directly through Zoom. This is going to be every Monday, Wednesday, and Thursday from 3:30 to 4:30 p.m. And this is for everybody, whether you're in the in-person section or you're coming through online. It's the same exact Zoom link right here. I use this for classes and for office hours. There could be other people in there. I'll just go in the order that people showed up and that kind of thing. I'll keep a track of that. But usually, depending on when I put these hours, sometimes they work really well for students. I get a bunch of people in Zoom or in room 220. Other times I feel like I picked a schedule that didn't work for anybody. If you're one of those people, if these hours look terrible, if you're working, taking other classes, just go back to this one. Send me an email and we could work out a time to meet one-on-one and do whatever kind of office hours or questions about the course we need to discuss. Any questions about that so far, folks? Okay, so that's ways of contacting me, that kind of stuff. We talked a little bit about the course text. I'll skip through the course objectives, but to, well, kind of paraphrase, really you're just continuing on what we did in Calculus 1. We're going to pick on more integration techniques, look at some more applications to integration. Those will always be exciting. We'll do some stuff that ties into Calculus 3, looking at parametric curves. So interesting curves that came from a function that can, on paper, look like it failed the vertical line test because it's a function of multiple variables or parameters. But the trickiest thing about 1175 is the sequences in series, Taylor series, Maclaurin series. That's where we'll spend a lot of time, go really, really carefully. But keep in mind, let's see, where is that? Sequences in series, this is the hump of the course. It does feel like a lot of work getting over that, but once you're clear from that, a lot of people have found that Calculus 3 is kind of just a breeze. I shouldn't say that. It is still hard, but you go through a lot in Calculus 2, and then in Calculus 3, it feels like you're refreshing Calculus 1 to a very high degree. So if you are up for Calculus 3, it doesn't just keep getting crazier and crazier and crazier like this material seems like it will, but we'll get through it. Well, we discussed homework. Homework is pretty traditional by accept homework from online, whether you scan something or send me a digital file. This is some extra advice on formatting your answers. Sometimes I'll ask for exact values, and this is what I mean right here. Other times, problems will tell you to round to 2 decimal places, and that might be what's expected of 0.87. I also should mention that for Calculus 2, it is sometimes a pretty tough course. So now's a good time to start thinking about, do you recognize anyone in class? Have you worked with anyone in a group before? Forming groups, working your homework sets in groups, sometimes is one of the best way to actually learn this kind of material. There's really kind of 3 levels to this. There's the level of, yeah, I recognize what's going on with this math. There's a level of, yeah, I can do it. I can solve these problems and hand it in, and they're correct. The highest level of learning is, can you explain it to a student that just doesn't quite get something? If you can explain it to someone, you are working at a really high level, and that just forces retention. You're going to dream about it at that point. You can't forget it any longer. That's the purpose of groups. When you're explaining things to each other, that is one of the best ways to learn mathematics, I'd say. You're all welcome to learn in groups. All I ask is, be sure to work to hand in your own original work. So no direct copy, but if you have the same kind of solutions because you all worked on the same problem, that's what I would have expected. Any questions, folks, about the homework component? Okay, well, there's really 2 components to your grade. There's a homework sets, there'll be 1 per section, and then there's the examinations. I'm not sure if this still is allowed by the math department, but it's on the syllabus, so we'll stick with it. Exams are a closed book. I'm going to make them be open notes. There'll be a single page of this size, 8.5 by 11, but that means front and back. So 1 page, both sides of this size will be allowed for notes on this course. There are certain things that I would provide on an exam. For example, if you scroll through the Moodle website, just poking around, you might have saw this document right here. I think I posted that like today, so you might have missed it. If you open that up, this is an indication of formulas that must be memorized for calculus, and I think I put in something else. No, I had a different file here that was supposed to be formulas I am providing on the exam. I need to fix that one. Let me just hide it for the moment and come back to that. But I indicate things that will be on the exam itself. So that way, when you go to write out your formula sheet, you know what's excluded, what is included, and that kind of thing. Also, when we're getting closer to this exam, probably about this weekend here, a couple weeks out, I'll start filling this out with the actual coverage, what sections, sample problems, and that kind of material. So let's see. I forgot where I'm at. Any questions at the moment while I think about it? Yeah.
You mentioned your office hours, I guess, almost the tutoring.
Mhm.
Is there a tutoring center on campus?
We
Outside.
We do have a tutoring center, but if I'm being completely honest with you, this campus has had some really rough times. Room 220 is the tutoring room, and it's just not well staffed. So instructors like us, me, Pageant, and Randy, we're the ones staffing the tutoring center at this point. You can get online tutoring, but that's usually going to take you to someone on the Pocatello campus if you did it online through a Zoom option. So it's pretty limited on this campus, unfortunately. And that's the reason I kind of opened up office hours to being on Zoom as well. And if these hours don't work, by appointment at the same time. So yeah, that is a downside of this campus. We don't have a great tutoring center. The hope is we can get some student tutors to start staffing it a little bit more. So if you feel like you've got a great handle on, say, intermediate algebra, college algebra, trigonometry, calculus 1, let me know. I'll be happy to get you in contact with someone where you might be one of the people staffing these hours. We don't pay well. It's something like, I think it's $12 an hour, but you get to get paid while studying. And if you're helping someone with math, you're really reinforcing that stuff. So if you know you're taking a lot of math, if you're in a math program, an engineering program, and so on, that might be a good option. spend some time tutoring, and you can help our struggling little tutoring center down there. Other questions so far? Yeah, I'm okay with either. So if you work digitally, you like to type things out, that's completely okay. Just make sure you can read it once it gets printed out. So any Zoom level, that kind of stuff is just fine. In fact, if people get in the habit of typing up notes in a study group, you're welcome to share them as well. The only requirement on an exam is you have to bring in your own paper. But if someone typed out stuff and they just want to share it with the class, completely okay. If everyone has the same material on their one page of notes, that's okay with me. You just can't share that page from one student to the next during an exam. Does that make sense about that? Okay. I don't type out the notes for you because I found that it is a good experience for learning this material to go through the course, go through those definitions, and come up with your own curated list of what you want to support yourself on the exam. That in and of itself is a really great way to study as well. So I usually don't supply any of those notes. I leave it all up to you. So I'm not robbing you of that experience. These are great questions. Other questions at the moment? Yeah.
This one is about that, but, do we use the Tiger Guest, internet?
Oh, great question. I believe it shouldn't be Tiger Guest. I think you just want TigerNet. And then you're going to log in with the same student credentials that you would get into Moodle, for example. So I think you're looking for TigerNet. The port's right there, but the Wi-Fi can be kind of spotty sometimes in this building. I don't know if it's weird metal roofs or something. Other questions so far? Okay, I figured out where I left off. So we were talking about examinations. There's a lot of stuff on here, but in essence, it'll be closed book. You'll have support by a page of notes. I might myself add a couple 4 minutes at the very last page of the exam. Good idea to bring a calculator, just extra support, it's a comfort, but you'll know which questions are calculator questions. They're gonna be pretty obvious. So you'll also notice a lot of the stuff that we actually do, I never really pull out a calculator. So the calculator is usually for applied sections. When we're doing applications, we want to get a value with units and such. There's other things down here, but we'll come back to some of these kinds of stuff as they're needed and as we get closer to the exam date. Let's skip down to the exciting part. My courses are a little bit different, I think, from my colleagues. I usually weigh homework extremely heavily. In this class, it's practically a third of the entire class. So getting through your homework sets, you're basically studying for your exams. But I find people who are getting their homework sets done on time, even if you get a few sets in late, if you're getting them done, if you're putting in some really good work on your homework, you're rehashing what you're about to see once again on the exams. Those students tend to do really well on the exams themselves. The final exam is not meant to be anything special. I couldn't go any lower than that, so it's still substantial at 25%. But if you've done well in exams 1 through 4, every time I look at my grade book, I look at datas year over year, I have like 2 examples of students that got in the A range on all 3 exams, but didn't do well in the final. And those students still passed the class because I didn't weigh the final so heavily. Yes, go ahead.
Is there 4 or 3 exams?
Oh gosh, that's a great question. It's really 3. I taught this class last in 2020, right before COVID. I copy pasted my syllabus. So that's a typo right there. This is correct. There'll be 3 exams, and it's also on this day-by-day schedule right here. Thanks for spotting that one. That one is a typo. I'm going to come back and fix. There are 3 exams. Starting to get a big page going so far, but we'll get these things corrected by Wednesday. Thanks for spotting that one. Yeah.
The day-by-day schedule is correct?
Day-by-day schedule is correct, yes. So we're right here. It's mostly a firm schedule, but if we decide, for example, we need more time on an applied section or anything like that, we can take extra time on any one of these sections. So I don't have review days built in before the exams, but we'll be sure to review substantially before the final exam itself. Oh, and sorry for the online folks. Chat's kind of tricky for me to pick out because it's like a little pop-up I have to see on the bottom. I will not too late on this one. And thanks for that question, Erilyn. I don't have an attendance policy. So my entire grading is really just based off your work product, really. your homework, your examinations. That being said, definitely try to attend as many classes as possible. And it's always going to be easier to kind of get through the course the more you're present. Any other questions or comments? Yeah. Yes, absolutely. Yeah, I have some pretty long problems in the homework set. That's something that's new in calculus too. And you could do a long problem. By a long problem, I really mean sometimes it's a whole page. And your answer could be totally wrong at the very bottom, but you might get almost essentially all the credit if your process is right, but maybe some of your numbers got a little bit flipped. Or maybe it was an algebraic error that I could see myself making, but it wasn't the thrust of the problem. It wasn't really a calculus mistake. You get the majority of the partial credit. That being said, if you have a problem that you turn into homework or an exam problem, and the answer is right, but everything here, if I can't understand the process, or if everything is incorrect, you might lose a majority of the credit on that. So my grading is very minimal on the answer. It's mostly emphasized on the process, the step-by-step solution, the way you got to your answer. So a numerically wrong answer could potentially be almost all the credit, and sometimes a correct answer could lose a lot of credit. I give a lot of feedback when I grade these papers, so there'll never be an answer. I shouldn't say that. Most of the time, you'll never have a question in your mind, why did Mike mark me wrong here? How did I lose points? But if you do have that feeling, especially on an exam, ask me about it. We'll take a look at it and we'll see what went on there. Sometimes I do make mistakes. I could have just missed something that you put in there. But does that answer your question about that on grading? Awesome. The way I grade your homework is going to be entirely similar to how your exams are graded. So partial credit, those kinds of things are all emphasized there as well. And that means, like I said before, these really are in a very strong degree, just like your exam questions. They're going to be a little bit longer because they're untimed. I try to make your exam questions short and sweet. But if you're doing well right here, you're essentially practicing your exam, and the feedback I'm giving you on those problems are meant to get you where you need to be when you do them again on the exam. So you're not missing credit on those same kinds of little issues or mistakes. Well, that's about 37 minutes of talking, but that's pretty typical for an introduction day. Down below here, again, is the day-by-day schedule. The only things that are firm are stuff like, Labor Day has got to be on September 2nd, and the exam dates are also firm as well. Moving those causes just chaos in everyone's life, so I try to not move those at all. Our final exam is usually at the worst time ever, but I can make different arrangements. I give other final exams. If that doesn't work for folks, we can make something better work out. I always feel a lot of regret when people are taking an exam for 2 hours up until 10 p.m. I mean, this campus closes at 10 p.m., but the registrar are people who control that, so you could email them if you like, if that's a terrible thing, but we'll work around that as necessary.
So there is a big difference from 1 to 3, it's going to be like normal class hours?
These ones right here? Yes, that's correct. So if you were coming into this class as an in-person student, there won't actually be a class this day. This could be confusing if you're coming in through Zoom. On the schedule, the 16th of September, there will be no class. We'll be doing an exam in here. And for the remote students, the online students, we'll be making the arrangements for the various testing centers as well. Other questions so far? Yeah.
I'm just curious, just because I've had a couple of your classes now.
Mhm.
On the first 3 exams, are any of those being dropped for any reason?
Oh, I'm glad that you asked that. I do have an extra credit policy that I've been doing for a long time now. I don't think I was ever supposed to do it in college algebra, but they never got back to me on it. So there's that. But one extra credit policy that I do put in, just because I think is fair, is at the very end of the semester. So this is like December, probably 11th or the 12th. After your final exam has been graded and all is said and done, I go back to all the data and I'm going to drop the lowest exam amongst exams 1, 2, and 3. So that way, if something happened, if maybe, for example, you had a rough start in Calc 1, maybe these sections are kind of busy, but you got caught up, but a low score in exam 1 kind of dropped you by a letter grade for the whole semester. By the time you get to the final exam, sorry, I said that policy wrong. Let me go to exactly how it should go. I said drop the lowest grade, but it's slightly different. We go to an actual one. Need to do one that's recent enough. This was the calculus 2 I did when we all went to remote learning with COVID. Okay, here it is. Thanks for that question, Eric. So this is what the policy actually looks like. I misspoke when I said it the first time. If your final exam score is larger than your minimum score among exams 1, 2, and 3, your score on the final exam will replace that minimum score. And I don't write a nasty final exam, and that's often an exam that I do curve at the very end. It's the curved final exam score that does replace that minimum. So what that means, again, now that I'm back on track, if you had a rough exam amongst exams 1, 2, and 3, but you retained that material on the final exam and came back strong, your final exam grade will overwrite the minimum grade amongst these 3, if it's higher. It's not an opportunity that would actually hurt your score, only help. And last time I did this for last semester, I think a close class similar to this one was linear algebra. I think about, if I'm remembering right, close to 2/3 or 3/4 of the class did have that extra credit go into effect for them. So it is something that does often help out quite a lot. Other questions so far about that or other things? Yeah.
So on, Moodle,
Mhm.
I'm looking at 2 classes, is that normal? Actually, I see math 1 and 5 twice.
Yeah, it is normal. It's a little bit weird. Let me show you what's going on with that. I want to go to remove from view. Let me see if I can find those.
Yeah, that one.
Restore, 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 restore. Let's go back to this. And so here's the purpose of that weirdness you see in Moodle. There's actually a lot of Calculus 2 classes. So I think the in-person section is that one right there. If you open this one up, it's going to be totally blank. So what we've done is we've created something called a meta course. It's taken this section 05, this section, the online section, section 15, and this one, section E15, and just dropped it into one spot. So that way everyone goes to the same site. So it's going to be the one that has a picture is the actual thing you want to go into. And now that you mentioned that, I can clean this up a little bit. I'm going to make a note of this. I should be able to go to the settings and take these ones and just go hide. That should work out. I don't want to do it today because I don't want to mess it up. I should be able to clean up that view a little bit better for us so we are not guessing which is the right one. But that's the short of it. Go to the one with the textbook picture and you're in the right place. Let me put a note. Remove extraneous sections. Okay. Other questions, comments at the moment, folks? Concerns or otherwise? Okay. Well, we've pretty much introduced the course. There's a lot of stuff to talk about because, I mean, this is not a typical class when you put 3 sections all into one spot. Well, there's extra little administrative details we have to get through. For the people in this section, fully online, as well as E15, there's extra details that we need to discuss about how the exams will work. There's a Pocatello Testing Center, an Idaho Falls Testing Center. We've got one in Meridian, Twin Falls, and there's various other ones at different Idaho colleges. So I'll be coordinating with you folks directly, the fully online students, on getting those exams scheduled, finding the right testing centers and such. I've made contact with most people in those sections, and this should all be done well ahead of us getting close to exam 1, or otherwise that'd be going to be a really stressful week for everybody. So I'll be getting those kind of administrative details out of the way pretty soon, probably finalized by the 2nd week. Well, other questions, folks, at the moment? Okay, well, we're 45 minutes into introducing the course so far. That's kind of hardcore for the first day of class talking about these things. And there's a lot of things we talked about, so I might repeat myself just as a reminder. But if other questions come up, never hesitate to ask. Directly email, see me after class, before class, or in class as well. Yeah, go ahead.
So Pocatello has a student center.
Mhm.
Are the office towers listed here somewhere for that.
Oh, not in here, but I could add them. They generally have very good coverage on Pocatello, Monday through Friday. I think Friday it's a little bit reduced in the evening, but they do have great coverage. I'll post a link to that as well. So if you're on that campus, I think a lot of us are around that campus, you'll be able to get some good information there. So you're very welcome. Thanks for mentioning those things. Hello. Tutoring hours. I'm glad you folks are mentioning this kind of stuff because, again, this is what it takes. Doing Calculus 2 completely on your own is absolutely possible. Some people learn best that way. But I find some of this material is just best learned as a social kind of thing. The more people you can bring in to talk about this, whether they be tutors, me, fellow students, the absolute better. It's always going to increase your success. Well, I think we're about ready to take a look at a few things here. I don't want to go too far because this is Monday. I taught 3 classes today. I'm sure you all did a lot of stuff too. A lot of us probably work and such. So we'll go to 8:07 on most days. Let's take a look at just a couple review problems. I'll wait till we come back on Wednesday before we jump into integration by parts. This is where Calculus 2 formally will start. But for now, here's about how the notes are going to go. I just have to figure out how to get my windows working. Give me a moment. For those people fully online, it's hard to get a gauge of what in the world I'm doing. I learned this the other day that certain things aren't even viewable for coming in through Zoom. If you're wondering what I'm doing in Zoom, this is what it really looks like. So this is what my screen looks like. I'm trying to pay attention to here. So if you use any of the reaction things like raise hand, the thumbs up, thumbs down, that kind of stuff, I tried my best to pay attention to it. So I'll try to keep this always right here. It's hard to get the chat out at the same time. It just doesn't fit in. So when a chat happens, there's a red dot there, and I have to notice it. If I don't notice it, I'll ask help from the class. Anyone in person, anyone online, you could just say, hey, Mike, there's a chat or anything like that, and I'll try to get to it to pop it out right away. This is what it looks like when there's a chat on the page. Again, this is stuff you can't see if you're in the Zoom class, I think, unless the update changed something. So when there's an actual chat, this is what it looks like. I just have to pop it out, read through it, and then we have to minimize it thereafter so that we still have some real estate on the screen. But here's where the course starts. For me, I've taught this Calculus 2 class several times, and I found the hardest thing about it is really just getting started with the idea of a differential. We deal with differentials a lot in Calculus 1. It's used in, say, if we're using a U substitution to integrate something. But the more calculus you take, the more you realize the idea of a differential shows up more and more and more often. Already in integration by parts, we're handling 2 differentials simultaneously. So this is a great place to start. So if you have a function, and if it's differentiable, then the differential, notice the difference in those words, they're different, is indicated in this way. We take a dy to indicate the differential on the left is the derivative, and a dx. The dy, the dx, and the x are all considered different variables. X, dx are independent variables, and we think of the dy as a dependent variable. So at its heart, if we have to function like this one, x tangent x, and our goal is to calculate the differential, okay, watch out for that wording, it's kind of tricky. This is pretty much all you'd be doing. If it starts off as a y, you just indicate a dy. If that was a z right here, we would have started off with dz instead. Next thing we do is we have to differentiate x tangent x. That's a good review already. Anyone recall what rule we have to use for differentiation to differentiate that thing? Yeah, good call. This one's going to be the product rule. And there's different ways to do the product rule. In a Calculus 1 class, you usually do it a little bit more carefully, but some of these problems get a little bit longer. So this is how I would typically personally do the product rule. I would look at the first function, which is an x, differentiate the x right here first, And there it is, it's done. I'm going to put in a 1 just to say I differentiate x. Copy and tangent x. Next, we have a plus in the product rule. If it was a quotient rule, we use a minus here. I need to differentiate tangent x, but now I copy an x first. And when we recall the derivative of tangent x, it's okay for Rusty. Good call, secant squared. I had to review that a week ago. I was getting a little rusty, I noticed. That one is secant squared x. So that's a product rule. The process isn't quite complete. All I've really done is differentiate this part right here. Here's where a mistake can easily kind of creep in. It's one of those really subtle mistakes. You might not lose a lot of points on this as a homework problem or exam problem. Sometimes I literally take off a 0.5 or a 0.25 just to indicate, hey, there's something small that we ought to look out for. So to finish the process, I have to put a dx in. But there is a mistake on this whole line somewhere. Anyone see what the mistake is, the error? Good call, absolutely. Definitely, I should simplify that. And the parentheses are major too. Without the parentheses, it's not clear what we really mean. Dx is literally allowed to distribute through these things. You could have said tan x dx, x secant squared dx, it just would look funny. But a parentheses is actually required right here. And these things seem like small issues, truly, until we get into differential equations in chapter 9. Suddenly in differential equations, all these little things like differentials, placement of dx, dy, the fact that there's parentheses, they really do matter. And so we'll make a big deal out of them as we are looking at these small minor issues. But I like what you said earlier, this is not even simplified. So the best answer to write here is dy equals tangent x plus x secant squared x dx. I put parentheses on that one there. Sometimes I drop those parentheses. These are considered a stylistic choice. So it's up to you whether you maintain function notation with your trig functions or keep it left off like that. Well, any questions, folks, with computing a differential? Okay, so that's one of the things that, it doesn't seem like it's a big deal in Calculus 1. Even after the u substitution, it just seems like, well, that's an odd thing we do. But in Calculus 2, we start to realize we use a differential a lot for a lot of different reasons. And this is just our review problem on that. I think this review section is a little bit trickier. Some of these problems might look familiar. Some of them could look a little bit strange. If they look strange, that's okay. This is a review, and some of these are tricky problems. Let's see if we can do one more problem. How about we end today on part A? Does that sound all right to folks? Awesome. So let's do one more integration, or this is our first integration rather. It is a review problem, so this is review from Calculus 1, but stuff we have to do all the time still. So we might as well start here. In order to integrate this thing, I cannot integrate x and get an x squared over 2. I wouldn't even know how to begin integrating sine x squared. So the fact that there's two things multiplied together means we need a new method. I'm not trying to find a direct antiderivative any longer. Anyone happen to know what the method would be called on this one? Absolutely. This one's a u substitution method, where already you do have to make use of a differential. So for a u sub, that means you're trying to undo a chain rule. We're reversing it in a sense. That means you're looking for a good inner function as a candidate. Typically, this is a good one. If x squared is here, you have a function composition. Function compositions are oftentimes a dead giveaway of what u should be. If you make a u at x squared, it may or may not work on the problem. When it comes to u substitution and integration by parts later, it's more about just trying something. If it doesn't work, we would try a different one, process out. If it does work, we'll keep on it. But it's more important to just get into the practice of experimenting and trying different things, because there's no direct formula for what u should be. And all I've got is a mnemonic for integration by parts. A lot of this is just guesswork, trial and error, and going by feel. It always seems weird in a math class. But as soon as you have your u, you need the differential. Here we had a y function, so we started as a dy. Here, if we indicate it as a u, we would do du. So du is now equal to x dx. So I differentiate, oh, that was close, right? There's something missing here. That should be a 2x dx. Let's see if we can space that better. One thing to keep in mind about this class is, this is recorded, it does go to YouTube, so mistakes are forever on the YouTube platform. So participation is encouraged. The moment you see a mistake, just feel free to call it out. Never consider it rude. I can miss a lot of things if I say on a first day of class or something like that. So there's my du. Looking in here, we've got an x, we've got a dx, and there's different things you could do with this too. I've seen different solutions, different strategies. Depends on who you might have learned this from, who you might have tutored with. I typically pick a technique that's more common to what our author might have done. The author of our textbook would have taken that 2 and divided it out to give a 1/2 du equals x dx. So now where you see the x and the dx, I'm going to directly substitute in 1/2 du, and here's how it all comes together. Now, 1/2 is a constant. You could put it right inside the integral sign, or you could just chunk it out to the left and deal with it later. I do this a lot because when you're integrating, sometimes you want to organize and simplify as much as possible. It's a way of focusing on what matters. This is now extraneous, the 1/2. Du still has to go here. This is about correct mathematical notation at this point. And what do we have left? X dx made up the 1/2 du. We still have a sine function, but the input to that sine function is now u, where there was once the x squared. Any questions, folks, with that first step in u substitution? Okay, because it's a review problem, I should have said what the method was. This is a u sub. On these notes, whenever I'm making an extraneous comment, I usually use a pencil tool, something along this color. That way, if you're thinking of what should I put in the homework, it's usually this stuff. Orange things are just comments or anything extraneous that's going along with the notes for the lecture. So now, next step, let's carry in 1/2. We're ready to get an antiderivative. I know it's going to be a cosine, but do we need a positive sign or a negative sign on this antiderivative? Good call, folks. It is negative. I forget this all the time. It takes me a minute to think about it. Usually the thing that happens in my head when I'm thinking, what is the antiderivative of sine? This is my literal stream of conscious thought. I know it should be a cosine, but the derivative of that is negative sine x. I'm missing a negative sign, and so I just include it right here. Yeah, I'd like that. Just put it right here. I definitely wouldn't want to put it there because now it looks like subtraction. I have to put parentheses to indicate the multiplication. So just throw it right out in front. Negative cosine u. Now there's 2 problems here. This isn't the answer. We could lose a point if we end it right at this stage. Anyone spot one problem or another?
Plus C.
Good call, folks. So on Zoom, we have to have a plus C for a constant. And in class, as Rajab said, if we do a u substitution, we have to unwind it and return to the original variable x. Those are kind of subtle things, but they're still important. And so here's our end answer. Negative 1/2 cosine of x squared plus the constant. The constant is, again, one of those little things where I sometimes forget to put that in, but it actually really matters. In differential equations, forgetting that can throw the entire problem off. It throws it off badly. It's not as if your problem's a little bit off. You can miss the whole thrust of the question without that constant right there. So it's one of those things where, let's say you did it at the first exam. You never put this on your exam paper, you'll miss a point once as a reminder. Same for your homework. But it is worth a point to get that thing in because of its importance. Things like these are a little bit minor, but it's just good practice. We always return to the original variable. If you forgot that on an exam, that might be minus a 1/2 point, something along those lines. What we did, folks, that's our review on this kind of thing. And let's suppose that was a real exam problem. If you wanted to check this out, you had extra time on your exam, I tried to bake in a little bit of extra time. Class is 67 minutes, so I'm writing a 50-minute exam for extra time for you to look over, deeply think about some of your answers and things. The check would be show -1/2 cosine x squared plus constant prime equals the integrand. That's another fancy word, but it comes up so often, it's a disservice to not use it in class. By integrand, we mean that whole thing right there. Let's use an arrow. I'll leave the check to you folks. All you're doing is using the chain rule to verify that if you differentiate this, you should get that, x sine x squared. But I'll leave that one up to you. Any questions at all, folks, on this first integration problem here? Okay, this will be a good stopping point for us. Any last questions at all then before we call it a night? Yeah.
Okay, should I ask you just a second?
Oh, no worries.
I just want to clarify that. I'll be honest, calculus won't take time, but I don't.
It could be a bear for sure.
Right.
Yeah,
The plus C is because it is a indefinite.
exactly.
Okay.
So this one right here is indefinite because there's no lower limit or upper limit of integration. What we're actually getting is a whole family of different functions for which, if you differentiate them, you get this right here. So that's the derivative of this function. That means these, when you put in a value, will specify the slope of the tangent line of these things. Slope of the tangent line doesn't affect the constant because your whole curve is just moving up or down. Your slope is unchanged. But if you go to, say, this one, that's a number. So here we're finding an antiderivative using the fundamental theorem of calculus, where our output is a numerical value. So that's the one thing that's also subtle about these things. And like you said, absolutely, constant is only because it was indefinite, no lower or upper limit of integration. Other questions so far? Yeah.
So this homework is due on the 20th.
Exactly. This homework assignment is relative to these problems out of the textbook. I'll have these posted as well. And let's say, for example, I'm saying it's due on the 28th. What I'm saying implicitly is, I think it should be done on the 14th. I think I probably will get through with it. But if we just need additional time, or hang on, the wrong day, I think we'll finish it on the 21st. But if we needed additional time and we end up finishing it on the 22nd, I push the due date back one more. So I'll reflect the due date so that there's always a 1-week turnaround from when the section is completely finished. Other things that are going to happen is after class, this disappears. And what we do is we go here and we just upload where we left off. That when we come back to class on Wednesday, you'll always know where you're at. So let me close that out. Oh dear, I think I closed out the Moodle webpage. I'll have to come back to it and put that on there. But other questions at all, folks, before we call it a night? Okay, well, have a great evening, everyone. If you have questions after class, feel free to stick around. I'll be happy to help out. I usually try to get out here about 8:30. So if there's a lot of additional questions, let me know. I can contact some people so no one's panicking. But have a great night. See you all on Wednesday. You bet.
Thank you.
Absolutely. Have a good one, folks.
Thank you.
You bet.